Hello everyone, I'm Xiaogang. Okay, in this lesson we'll finish the third section of this case. Here, you can see it's already completed. And you can see a red ball, which is emitted from this spot. And then this ball collides with this object. Then when it collides, it gets distorted. This is its life cycle. Okay, let's take a look at the steps. First, it created an action, a mapping called manPin, so that an operation can be performed. Actually, it involves an actor class. Well, this class does not inherit from Punk, nor does it inherit from culture. This is obvious, because it doesn't need to receive input from our player. That is, it won't accept input from our input devices. These types of inputs. It also does not have any AI behavior. It is just an actor. Then here we add a collision component. Pay attention to the syntax here. It uses visible defaulters only, and its category is parser. Then here is a pointer. Note that it is a pointer. It has not actually been created yet. Then here, it first creates such a root node. This is a root node. Then it creates our collision component. Then it sets the collision component's spherical collision radius. Then complete our root node. Assign a value to this location. Actually, this is not very good here, because you are creating it here. Since you are going to use it to do it, this is a non-true check. Yes, I think this part is not well written. He is saying that if the root node is null, then create it. If the collision body is null, then create it. Finally, assign this. But writing it this way is also fine. Yes. Next, add the movement component for our projectile. Pay attention to this projected movement component. This component is quite special. It's often used when we create projectiles like bullets, or arrows, or symbolistic trajectories. We use this projected movement const. Then here, it is declared here. Yeah, then similarly, in the constructor, it is initialized. First, this object is created. Then here, its update root node is set. This is very similar to our movement component, right? Then an initial speed and maximum speed are given. And here, it's about whether to follow it. It rotates along with the speed, whether it bounces, and this is probably the bounce string. And this should be a gravity coefficient. Yep, so after initializing roughly these variables, this can also be set in Blueprint as well. No problem at all. It provides default values in these places. You can make further adjustments in Blueprint. Overall, the constructor looks like this. And here, it has overridden a function. This is the one we need to call to activate it. And this is mainly the direction given. You can see. So in this implementation, we take this direction. That is, we get our projectile component, and then take the position of the projectile component, which is the direction. That is, its unit vector, and then multiply it by its initial speed, thus obtaining an initial launch vector. Yes, that's roughly it. At this point, we need to bind an activation. Actually, we need to define a fire. And in the fire section, we haven't written it yet. Let's bind it first. So for this fire, we actually just need to call this function. This part is still empty. It hasn't been written yet. The following part is more complex, because it involves something like how to do a RD to 3D or conversion to 3D. Actually, we often have this requirement when we are making an RTS. We need to take our mouse cursor from our screen monitor and convert it into 3D space. We need to cast array. So in this case, we need to consider it. Actually, it's the same, where we generate from, and then which type of projectile. Actually, we already have some relatively common methods. That is, undercloser. If you have used it in Blueprint, it means it can very conveniently cast array from the screen. And then at this point, it defines a muzzle, which is equivalent to an offset of the camera position. This is an F vector. Then it defines a projectile. This subclass means you can fire a fireball, or you can fire an ice spike. So what exactly is fired? We want it to be specified by Blueprint. Right, we usually specify it in the Blueprint's default values. After we specify it, this class of ours will fire this type of weapon. Generally, it won't happen that I cast a spell, and it's a fireball with an ice spike. If the spell is fire-based, it should be all fireballs. If it's ice-based, it should be all ice spikes. So we only need to set the default values in the blueprint. Note on the blueprint int sense. Make a simple change. Once it's done, it will look something like this. Then it compiles. After compilation is complete, we can see here, it starts actually writing this emission function. First, we need to emit this class. This is the UCAS type. In Blueprint, it is purple. It must exist. So here, let's first do this. AddActor USIR pi_int. That is, we get the eyes of this object, its position at the scale opening, its location and rotation. Then we give it a simple offset. After the offset, take it from the camera space and convert it to world space. So it's very much like our camera position. And here it has a conversion with offset and rotation. Adding this, it goes into world space. And here, it also does a slight cleaning. Anyway, this part is mainly for some adjustments. This pressure value, yeah. And after cleaning, finally, get this word. Then ultimately, it accomplishes this through spawn word. Then in spawn order SpawnActor, it has some parameters. You can see. So who spawned it and who is its injector? Usually we set the injector to this control. That is who is actually provoking. Actually, it belongs to the gun, but we are controlling the gun. Then its injector can be pump, or it can be our player control. This depends on the specifics. See? So how do you define this in the game? At any time the provocateur, such an initiator-like behavior, then through the SpawnActor behavior, we generate this object. After it is generated, we then call this. The fare of the object we defined. In direction method, here we pass in the position of this gun muzzle. Okay. Good. So if we continue looking below, probably it is just like this. Let's continue looking below. This is the code inside its character class. After the final compilation is complete, then here is where we import the projectile mesh component. After importing it, you just need to specify it in our blueprint reference. Obviously at this point, you need to add another mesh to see it. Here it uses the classic approach again. Yes, it uses the classic hard-loading, hard-tated approach again. After loading is complete, perform a setup. After setting it up, its projectile class actually looks like this. Focus on the FireInDirection function. Yes. Then FireInDirection is actually the muzzle position we passed in. Multiply it by its speed and slide speed. And finally, a material was made. Oh, it's worth noting here that it still doesn't work within Blueprint. It's still done at home. So actually this material, instance dynamic, is an instance of a material. And that is done through this hard loading method. So if this materials is found, then here, through this economic function, created a materials instance. Then do some copying inside the instance. Then set it to these materials. Because materials is a host, set it to position 0. Set it in. Then here, for the static mesh, that is attach and describe our sphere itself. Then here we created a material. This is a PBR material created by double-clicking. Right, after creating the material, then paste its reference. Then replace this reference here. Okay, so in the end, after it's done, it looks like this. Good, okay, and here it means you specify it in the place. Specify this projectile. Here it hasn't loaded either. Actually, it's in our character class by T in TSubclassOf. There is a purple class selector. This way, you can fire this projectile, and then you can see in the scene projectiles being generated continuously. But actually, this will cause a lot of lag because it will keep flying to the border of this world. it might only after hitting the word border. It will then be destroyed. This is unreasonable. So we give it 2 life cycles. One is its maximum lifespan limiter. One is collision. A life cycle after collision. It currently has some issues. It will keep existing and will not collide with other objects in the world. So we can give it an initialized default lifespan of only 3 seconds. This ensures that after 3 seconds it will die. So this kind of, we just write it at the very end here. Then you can see this thing will keep decreasing after 3 seconds. At the same time, we have some collision presets. So this part has grown a bit. This collision preset, you can customize some collision channels. Mom, here, he created a new collision channel for an object, and then he will. So after you define it, you need to define how it responds to this collision. It responds to or modifies collisions with some object. Yes, it seems this image hasn't loaded. It hasn't loaded. We'll wait a moment. We'll show you again during the hands-on practice. The meaning is the same. That is, some things we allow to pass through, but some things can block it. Then, after we finish defining it, we will use this to find our collision software component. Then specify the collision file. Once specified, the code below will look like this. Then we can make it use the OnHit function, which is very critical. It is based on this U function, which should be necessary. Then this function signature will be very long. We will tell you later how to find this kind of function signature. Then here, to respond to its collision. When the collision is activated, it will call this OnHit. Obviously, this OnHit needs to be bound such an operation. Then in the parameters of OnHit, it does a destroy here. Yes, and at the same time, it will add an impact force. So it is very obvious that this is an OnHit. You can get the direction of the impact points and such, directly at an external force, as long as physics simulation is enabled. That is, he is doing this work. And then pay attention to this AddDynamic. It is a dynamic binding that we will talk about later, because it is a dynamic. So this thing must be a U function method to work. After binding like this, then this SphereComponent can respond to collisions. Most beginners will probably, this is the most error-prone part. That is why there is no collision response. It is right here. It must have U function, and the function signature wasn't written correctly either. This is the mode constant, the place where the problem occurs. We'll skip this code, and in this place, it placed a random static mesh, drag it in, then adjust its size. Then the design is completely fine. And these are basically our game logic. That's about it. Finally, we want to add some UI. So at this point, we downloaded the crosshair. Import it here. It should probably be a texture. Right, then we create that HUD. After creating the HUD, the OCHU is actually our head-mounted display. It's actually what we often refer to as the screen display. Yes. Then after creating it, in this projection display, it specifies that this texture is in the HUD. So it actually recommends the dry hued method. Actually, sometimes we use UMG to do it. In this case, it draws directly. Let's see how it performs this drawing operation. So actually, in this place, it first defines this canvas. Find the center point of this canvas. This size is roughly this size. And at the same time, then, in this place, apply an offset to this texture, which is equivalent to doing an alignment. Yes, then, in this place, specify a position for this texture and the texture, then some parameters and settings, and finally let it drive it. Writing it this way is quite cool. But maybe we don't always do it this way, because we just attach it directly to our main UI. This is a relatively common way to write it, like this. Okay, after doing this, we create our blueprint subclass again, because sometimes we might need to change our crosshair. Some people prefer a round crosshair. Some people prefer a square crosshair. So we expose this texture parameter, then we can achieve a crosshair replacement. That's it. Then here we can specify it in our game mode. We just need to use this HUD. Here select the crosshair texture we just created. After everything is done, we can see the effect we saw at the beginning. Overall, this chapter is quite complex. You can see there is so much code. Okay, we will try to cover this part in the next lesson. Finish it. Explaining this content. We will end this lesson here. Thank you everyone.